this is what you have to start with. And yeah, you have this example as your first one. So you have a 0.15 mole per liter solution of hydrochloric acid, and it's used to titrate. So when it says it's used to titrate, that means that it is the titrant. Okay? So since this is the known concentration, so just practicing our lingo here, this is the known concentration. So that's called the titrant. And you can also tell by the language where it says it's used to titrate. A 10 milliliter sample, so that's whenever we see the word sample, this is the unknown, of sodium carbonate. What is the concentration of the sodium carbonate? The indicator used was methyl orange. Okay, so there's a couple things here we'll make note of. Methyl orange, so this is where it comes into play, where we look at our pH indicators just to kind of get a sense of what's going on. So let's look at our pH indicators in our data booklet on, what are we on? Page 10. So find methyl orange. So methyl orange is 3.2 to 4.4, and it goes from red to yellow. So, so this, if it's exposed to, so it's like, okay, I get so excited about titrations, I want to tell you everything about it. Okay, so here, if we have a sample in here, is this sample an acid or a base? Sample is the unknown. Is sodium carbonate an acid or a base? Base, okay? So I'm going to write here, base, okay? Now, if in my burette, okay, and sometimes with these questions, it's good to draw a picture just to get a sense of what's going on, okay? Here is my acid, is the titrant, okay? So the acid is in the tube and the sample is in the flask. It doesn't always, it can be either way. So, why did they choose methyl orange as their indicator? Well, if you put methyl orange with sodium carbonate, what color would it be? Yellow, because it's basic, right? Once you add in enough acid that it's completed, it will start to shift to red, right? The perfect titration for this would be if you get a nice orange color, right? Because it would be before it goes way too far. A more accurate one would be an orange. So that's why, and you guys are going to have to be able to do this. Like if I gave you, I said this is the titration, this is the titrant, and this is the sample. What type of indicator would I use? So what you need to think is what is in my sample. Okay, if it's a base, you want to get something that detects when it's acidic because you're adding the acid. Okay, so I'll talk more about this as we go through these examples, but just have that in mind. Okay, also let's write out our chemical formula of what's happening here. Okay, so let's write out our chemical formula. So we have HCl reacting with, what is it, sodium carbonate, right? Okay, so our sodium carbonate, our base. Okay, so we're going to make NaCl and H2. No! Hold the phone. That doesn't work. You have to... Does it work? Because that's not what's really happening. Right? That is what's happening, but you would have to dissociate the base and do a Bronston-Lowry equation. Okay, we'll just leave it like this for now. Okay, we'll just leave it. But there's more going on there, right? Because that would dissociate and react with water to have a hydroxide because it's a base, right? You know what I'm saying? Remember that? Okay. So, I don't know if I like it anymore. Whatever, it's fine. All we really care about is the reactants, realistically though, right? So, we're doing titrations. I know, right? Yeah. Okay, so what do we know? Tell me something. What do we know? Which is? 0.150. What else do I know about my sodium bicarbonate? I mean sodium carbonate. Matthew, what do I know about it? Yes, because it's a sample. So 0.01 liters. Okay? Right? Yeah, okay. Cool. So I'm trying to figure out my concentration of my sample. So what we need to think is we need to find the volume used in reaction for it to go to completion, okay? This we measure on the burette, okay? If we can find that, we can find the number of moles, do our mole comparison, and be happy with life. But I need it balanced, don't I? Let me just see something. Yeah, I need to balance it. 2 and 2. Okay. So, what you could be given as, you know, how did they do this? Okay. So, the first trial, and this is how you set up your titration data usually. Your first one is usually an overshoot. That means that it was kind of crappy, you went too far, but it gave you an idea of when the end point would be, so you know when to really slow down. That's usually, so usually your overshoot is a write-off, unless you're really awesome, you know, and you're super slow, but then that's boring, right? So, bless you. So say the data here is 13.3 mils is the final volume, and the initial volume is 0.2 mils. And that's based on the reading, looking at the reading on the burette. It's not like you start with 0.2 mils and you, yeah, so, okay. So how much volume of HCl is used? 13.1. And this end color was red, so it went too far. It was too far over, so it wasn't good data. So next, so they did another one. Well, now their burette is up to the 26, and ours actually reads the other way down. This data is from a burette that reads up. 26, say they had 13.3, because look at this. This is always going to be the same. So if this is the final volume, then that's the initial volume of your next trial. Okay, right? Okay. So then, what did they have? 12.7. Okay, so they didn't overshoot, so they probably have an endpoint color of orange. Great. Okay, some more data, because you got to have 3 trials that work. So see that 38.8 is the final volume, and 26.0 is the initial. See again how these are the same. Okay. 12.8, and it's orange. So another good trial. So these are only 0.1 mils apart from each other, so that's valid. It's good. Okay. 13.4 and 0.6. Why are these numbers different now, do you think? What did they have to do in their experiment?
Add more titrant.
They had to add more titrant to the burette. Yeah. So they kind of had to start from the beginning. So the difference, 12.8, another great result, and it's orange. So what we're going to do now, this is the volume of the titrant that was used. We're going to take that average and use that in our stoichiometry now. Oh yeah, don't go too far. You're overshooting. Okay, so to find our average volume, you add the 3 volumes together, and I gave you that whole page to do all your writing and your calculations, so feel free to just write all over it. And divide it by how many there is, so obviously 3. And again, you do not count the overshoot. Never count the overshoot. .7, etc. milliliters. So we already wrote out our equation. We already wrote down what we knew. But now this is our new data that we get to add to our equation for our stoichiometry of what we're given, because we found that out in our experiment. So that's our average we're going to use in our calculation. So now you can find your moles of HCl that was needed to complete the reaction. So moles is 0.001914. So we do our mole comparison. So wanted over given, because this is our wanted, this is our given. So wanted over given. And then you can find the concentration using C equals N over V. So your concentration is 0.0957 moles, and then you can put it into scientific notation.